Hello, 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 hello. This is the seventh stream, seventh day, not the seventh stream. We have done more than seven streams of uh, animating water droplet falling into a cup in Android OpenGL. So, yeah, I should be more enthusiastic. I should be more energetic because earlier I used to give even promises that I would do 6 to 7 hour streams for this. But currently, I'm starting at like around uh, 1:30 and all that. So this is already starting from back foot. But this is also because of the fact that I'm currently working on the water model for this, and water model is kind of intimidating as we had a long rant, preaching rant on the initial part of yesterday's last stream. So we will anyway start working on this. And the most important point in any of the streams is I should be enjoying the process because there is some sort of intimidation, some sort of trauma associated with this particular world of things, right? With the frame buffers, with the modeling. Because I had attempted these earlier, I had some sort of success in some of them, but vastly there are many of the concepts are intimidating in some sort or the other. I've never talked about it like this as in explicitly somewhere, but I would like to get a much better grasp on these concepts. So this is wired into my brain, so that is also giving me a factor that is also kind of motivating me to do this again and again, because I know for a fact that once you understand these concepts, you will be able to simplify it much better. And also I love some of the images that come out on paper on research papers, right? Year in year out, those were the things which initially drew me to this field anyway. So we were yesterday last when we left, we were working on the water model, which was pretty comprehensive. Now, before going to the water model, we will just first check maybe what is faster in shaders, right? This is just a starting point. Are if statements slow in shaders? Because I feel there is going to be a lot of if else statements in the shaders. So man, there is some big uh, okay. What is the question? Do conditional statements slow down shaders? I want to know if statements inside shaders, vertex or fragment or pixel shaders, are really slowing down the shader performance. For example, is it better to use this instead of using this? In another forum, there was a talk about, here the guys are saying that if statements are really bad for the performance of shader. Also, here are the talk about the performance issue. Okay, so basically, he's asking the question whether if statements slow down shaders. What is it about shaders that even potentially makes if statements performance problems? It has to do with how shaders get executed and where GPUs get their massive performance, computing performance from. Separate shader invocations are usually executed in parallel, executing the same instructions at the same time. They are simply executing them on different sets of input values. They share uniforms, but they have some different internal registers. On term, for a group of shaders all executing the same sequence of operations is wavefront. A potential problem with any form of conditional branching is that it can screw all that up. It causes different implications within the wavefront to have to execute different sequences of code. This is a very expensive process whereby a new wavefront has to be created, data copy over to it, etc. Unless it doesn't. For example, if the condition is one that is taken by every invocation in the wavefront, then no runtime divergence is needed. As such, the cost of the if is just the cost of checking a condition. So let's say you have a conditional branch, and let's assume that all of the invocations in the wavefront all the invocations in the wavefront will take the same branch. There are three possibilities for the nature of expression in that condition. Compile time static, okay. The conditional expression is entirely based of compile time constants. As such, you know that looking at the code, which branches will be taken, pretty much any compiler handles this as part of basic optimization. Statically uniform branching. The condition is based on expression involving things which are known as compile time to be constant. Whether different hardware can handle different branching types without divergence. Also, even if a condition is taken, the compile, okay. So basically, this is saying if it is a uniform value, it wouldn't affect performance that much. But just note it down anyway. If it's a uniform value, it will doesn't affect the performance that much. But in case of if it is a uniform value, it will not affect the performance that much. But in case of the attributes which are dynamic, it will affect the performance basically. So we'll add this as a point.